Welcome back for part 2 of this Ironman tutorial series. On the screen right now is a look at where we will end up by the end of this video. Thank you to Scarbang for the comments on the channels and for requesting this video series on Ironman. If you guys have any videos that you'd like to see made or topics discussed, leave a comment. If it's an interesting topic or a good challenge, then I'll make a video on it. The conclusion for part 1 of the Ironman tutorial left us with this. We have a series of splines that accurately outline in three-dimensional space the Ironman helmet. This is our framework that we will build off of. In part 2 of this tutorial, I'm going to show you how we network those curves to create surfaces, and a majority of this is going to be troubleshooting, showing you mistakes that can happen and what you can do to mitigate that to create the best result possible. Remember in part 1 when I showed you the side of the helmet and how it had these discrepancies in the surface? I had networked it, we put it in Keyshot, and we were looking at how it's got some errors in it. And I said, don't worry about that right now. All right, well, now is when we do worry about it. On the screen, you can see that I've broken up that surface into little chunks. I created my own additional curves to divide that side of the head up into smaller pieces. And then I simply use the network tool, which is under the construct tab, to create these patches of surfaces. This gives you a consistent result. I dropped this in Keyshot with the current curves that we built from part 1. If we network them, the networking happens fine, but look at the result we get. Moai is trying to resolve the bump and ridge that we have around the nose with the clean curve at the bottom around the mouth, and this is the solution that it's finding, averaging everything out. It looks cool, and if we were doing our own design, it might be cool like that, you know, but it's not Ironman. So the solution, again, is to give Moai more information. So we need to move into that front faceplate and add additional curves that tells Moai, no, we don't want to average it that way. We need a smooth result. This is a great example of a more complex or troublesome spot you can run into. Look at the curves around the eye up into like the nose ridge area, a little swooping S. When we try to network the front of the mask using that curve as part of the calculation, that's how we're getting that weird kind of bump in the nose area. So we have to take those curves out of the calculation from Moai, because we want to tell Moai, hey, just give us a simple surface. So here's how we fix that. I create a plane above the model. Then I extend the lines on the sides of this portion that we're trying to enclose so that the curves become really long and they go all the way up to that plane. This way we can create a new surface that extends past the S curve, and then use the S curve as a trimming tool to trim away at the surface. Then the result is the curvature of a surface that we want nice and smooth, and it has the profile edge that we want of that little S curve. Now it's a matter of joining the surfaces together, and you can mirror it to the other side to complete the front portion of the mask. When it comes to the cheekbone area and the scoop down that leads down toward the mouth, what's important about this area is to look at how I built those curves. So I have added additional curves inside to give myself a framework to network the surfaces from. But see how there's a continuous line from the eye area and then it scoops down below? When we're adding these additional profiles, we're following the reference. So you're looking at how it scoops and you want to mirror that with your curves. And if you can make the curves have a kind of rhythm to them, a flow, that is what is going to help create consistent surfaces that will smoothly transition one to the other. When working off of reference like this and we're making something that already exists, you can get stuck in a mindset where you're leaning on the reference for everything because you want to make it accurate. But there are times, just like in this cheek area, you got to remind yourself that you're in control and you're the one modeling. So you have to get in there and make the curves yourself, turn on show points, adjust it, do a network, test it, move the camera around and compare it to your reference. And just get it to look right, because there's no one image that we can pull from to get the exact curvature. For the ear area, let's use the tools and techniques we learned in the basic tutorial series. Use the curves that we've drawn extrude them out into solids, and then chamfer, fillet, Boolean subtract, and boom, that takes care of that area. And remember, we still have all the other tools at our disposal. We can extend, we can trim, create planes to use as cutting objects. So that's what I'm doing here to get that chamfer cut in the center area. So we're moving along. A few of these areas that you see complete, I'm not highlighting in this video, but after this entire tutorial series is done, I will release a time lapse of the entire modeling process that you can scrub through and see how I modeled anything that I am not mentioning in this tutorial series. It's time to tackle the vent piece in the top of the head. So we're going to take that U shape that we drew from the elevation view and project that, blast that straight through the top. Now, because this surface is not a solid, that means we can't use the Boolean tools effectively, but we can still use the trim tool. The way it works is you copy the surface as it is before you do any trimming. And then from the front view, you select the U-shaped line and the surface, run the trim command, and then delete out that center scoop area. After that's complete, press Ctrl V to paste the original surface back into place, and repeat the process, only this time trim out the bottom side. So what you're left with is two separate pieces. And then from there, I'm repeating the same process on the back skull of the helmet, projecting it all the way through. And then from the side view, I draw a line that lines up with the reference and the elevation that I've drawn. That is the termination point of the venting. You can see that there is that like center cowl, looks like a cowl induction hood on a car, and smoothly blends into the rest of the helmet. And then I can do a join surface on the back side of the helmet to combine what's left over. And the result is we have this shape here you can see in the perspective view. And the next step is to rotate that centerpiece down so we can create that scoop that slowly transitions into the smooth portion on the back of the helmet. And now that we've got that scooping downward, let's take that centerpiece and scale it inward. And that will create that chamfered inset that we see in the reference. From here, I'm copying the edges of all the surrounding surfaces so that I can create a new set of curves to work with. So I'll hide the entire model so I can just focus on this, and I'll start adding lines at the end of each curved segment so I can like isolate the pieces, right? After I have that done, I can select and network the individual parts. Now let's work on that cowl induction hood on the top of the helmet, that slit area. To do that, we're going to work with curves again. So I'll duplicate the curves of this area. I'll create a line that's at the termination point at the top of where the vent starts. And I'll use that shape. I'll offset it inwards a little bit, fillet the corners. And with that shape, I'll punch it down from the top view to create a new piece. I take that piece and we're going to rotate it down toward the front of the helmet. I will select that as the base point and then rotate downward. And that's what's going to create that smooth transition from the front of the helmet towards that vent area. Once that's created, I'll select the curves around the ring on the outside again, copy and paste them, and then extrude those downward, and that'll create the little sidewalls. If you grab the edges of that extrusion and scale them together, that will create an angle, a chamfer, that matches the angle of the vent in the reference. Once again, we make 2D curves of the vent, the actual vent itself, and then we punch that through the surface, and there we go. We got the hood scoop on the top of the helmet. All right, time to cut the temple up so that we can divide the front gold mask from the back of the helmet. Check it out. This is our first real look at the entire helmet, right? We got all the surfaces in. We networked the curves. It's looking pretty good. We're not done yet, though. We need to clean this up. We need the filleted edges. We need the perfect contours, the perfect surfaces. So stay tuned for part 3 because that's when we're going to take it to the next step. I hope that this helped you. If you have any questions, please leave a comment and I'll see you in part 3. Take care.